Hi, it's Grant from Dome Music Technologies, and this is our second look at the ACE Integrator module. This time we're going to expand on what we learnt the last time. So I'm just going to quickly set up a +1 volt input here, and because we've got the run permanent switch on, it rises from its initial voltage level up to 5 volts at a rate of 1 volt per second. So it will take 5 seconds to climb from 0 volts up to 5 volts. And because we've only got the 5 volt limit on the output, once it reaches 5 volts, the overflow light comes on and it stops integrating from that point. So what we're going to do is use that overflow output and get it to reinitialize the voltage back to 0 volts. So if we just take a lead from there. What happens is, every time it reaches 5 volts, it resets back to 0 volts, and what you've got is a simple rising, unipolar rising sawtooth wave, which is going from between 0 volts and 5 volts at a rate of 1 volt per second, so it will take 5 seconds to perform one of these periods. Now if we increase the input voltage, then that increases the number of volts per second that it rises. So if I put it from 1 volt up to 2 volts, you can see that the rise time is now halved. So it's going twice as quickly from 0 volts up to 5 volts. If we increase it by 2 again, up to 4 volts, and again it increases in frequency by 2. And again, if we pump it up to 8 volts, it's twice as fast again. So we can use the output of that to, let's bring in an oscillator, and we'll just put that into the frequency modulation input, and just take the that's actually still quite slow. That's because we're on the 1 second time base. So you can actually increase the time base so that it's, instead of being 1 volt per second for every the voltage input source, it'll increase by 1 volt for every 100th of a second. So it'll be much quicker, it'll be 100 times quicker than it is currently. So if I just switch that in. So if I just pull down the input voltage to a more manageable rate. So we've got, so if I just set it to 0.1 volts at the voltage input, that means that it will climb by 0.1 volts every 100th of a second, which means that it will take 0.5 of a second it will take 1 second to cover, let me think now. So we've got 0.1 volts at voltage in, and the output is increasing by 1 volt for every volt at the input every 0.01 seconds. So that means, I think, that every half a second it will go from 0 volts up to 5 volts. I think I've got that right. So if I increase this from 0.1 volts to 0.2 volts, it should increase the frequency by double. And again. And then if we go into the other time base, that would be 1 volt per input volt for every 10,000th of a second, which is audio rate frequencies. Another way to calm down the frequency of the output is to change this slope knob. So there's a linear relationship between the input voltage, time base, and the slope knob, which means that you can calm down the rate at which it climbs. So if we now switch it into the audio rate, we can calm it right down to LFO type rates. What we can also do is put it into the negative Vin rate, and you can see it starts to go down, but it's getting clipped at the negative 5 volt area because we haven't connected the overflow, the negative overflow, back to the initialization input. So do that, we've now got a unipolar negative LFO. So I think that's probably the best place to stop it just now, and we'll pick up some more advanced topics in another video. So bye for now.